Hello everyone. Topic of this session is actually a challenge faced by many organizations, and mostly it's late by the time they realize that network-focused firewalls are not enough. During this session, we will be explaining the differences between a traditional network-based firewall and a web application firewall. This session will be covering high-level approach and strategy for manager-level audience. We will also be covering technical hands-on demo for our geeks in audience. My name is Victor Monga. I work for VMware based out of Palo Alto, California. I specialize in solving tactical security and compliance challenges. I focus on security management and threat modeling. I've been in industry from past 16 years and loving every minute of it. Solving security challenges is my passion. Troubleshooting a network problem, looking at network packets is dream come true for me. I've earned few certificates like CISSP, VCIX, NV, CCNP, AWS, CCSK, and SANS GIX certificates. I am a community leader and volunteer for a few nonprofit organizations such as Cloud Security Alliance, Virtually Testing, and ISECA. For those of you who might be interested in learning more about me, please connect me over LinkedIn and or Twitter.
Hi, my name is Anil Dadani. I'm a technical account manager at Signal Sciences. I'm also a director of education at the Cloud Security Alliance Los Angeles chapter. If you ever want to reach out to me, feel free to reach me on Twitter at realanilsis or on LinkedIn by just searching for a Dadani or Anil Dadani.
A quick disclaimer. During today's talk, we will be expressing our own thoughts and opinions. Our employers are not liable for our views for this session. Let's start with a joke for my networking peeps in the audience. Today I was late to join my Zoom meeting. When my manager asked me, I said my network packets were stuck in traffic, and only network engineer giggled. With that, let's jump right into today's topic. From left to right, we have a responsible user who is using internet to access web servers. Between responsible user and web servers, we have network firewall and web application firewall. So let's do a packet walk. Responsible user is trying to reach to a web server over port 443. Network packet will start from responsible user's network interface card. It will arrive at the internet. From there, it will be received by network firewall. It will arrive at web application firewall of web server. If all firewalls allow the packet to pass, it will arrive at the web server, which is servicing web server over port 443, and communication will be established. Now, few things to consider. We have skipped so many steps of networking such as switching, routing, DNS, etc. But to keep our focus on this session, we would want to convey the message how packet traverse from network firewall and web application firewall for a legitimate traffic. So if life is that simple, then why do we need to even talk about firewalls and cybersecurity? We just illustrated what is an expected behavior from a responsible user. Now we will talk about someone who is trying to reach a web server with the sole intent of unauthorized activities to gain access for various motivations. If a malicious hacker tries to reach your web server over port 9443, which is not allowed from your network firewall, this network packet will be denied by network firewall. If same malicious hacker try to reach web server over 443, which is allowed by network firewall, it will work. Now by this time, malicious hacker must have learned that the only way to access or attack this web server is going to be over port 443. So network packets can be allowed and pass through network firewall. But what if he chooses to attack the web server using protocol-based attacks? So the network packet will pass network firewall using port 443, but malicious hacker can still attack web servers. And that's where you need a web application firewall protecting your web servers other than network-based firewall. Repeating the topic of this session, network-based firewalls are not enough. In our example on the screen here, we are showing that all network port-based attacks will be blocked by network firewall. All web application-based attacks will be blocked by web application firewall, also known as WAF. So, over the years when I have spoken about this topic, audience have asked me a question over and over again towards the end of presentation. And question is, can I use WAF only and not implement network-based firewall at all? So I would like to address that up front. If you choose to use only WAF, it is a bit slower and also a lot costly. I would like to explain this using a diagram. So on the screen, you see a red circle. Let's say it is a network-based firewall. Now within this red circle, you have a blue circle. Let's say it is Web Application Firewall. Within both circles, you have a web server that we want to protect within protective layers. So let's say a malicious hacker tried to attack web server using HTTPS attacks. It will be blocked. However, what about if this attack was a network-based attack and not an HTTPS attack? So, if this attack is a network-based attack, for my networking experts in the audience, you know it is costly to block a layer 7, which is protocol attack, versus network attacks, which is layer 4. So, if we can block layer 4 and if Web Application Firewall never sees that attack because it was blocked by network firewall, it is more efficient and less costly. Bit of a history lane here. When we have seen the first firewall in 1989, we have started this journey of firewalls. We are almost 30 years past that. Threats what we protected 30 years ago are not the same today. Threats and attacks have been involved. That's why we need to evolve our firewall strategy as well. As always, I remind myself along with y'all, nothing solves everything. But never get a technical product or a solution and then try to fit your business requirements based on the capabilities of a technical product. Let your business requirement justify for a technical solution. Let's take it a bit of high level and look at this holistically. I'm going to reference network OSI model layers here. We can have many choices when we are selecting a firewall for our organization. Most of these firewalls can be categorized into 3 categories. Layer 3, where we only check IP addresses, either source IP, destination IP, for a single packet. It does not matter which direction from one network to another. Layer 4, where we actually check IP and port number. So we don't only check IPs, we can create rule based on a port number along with an IP as well. Layer 3 firewalls cannot do that. Layer 3 firewall is only IP. Layer 4 firewall can have IP and a port. It also maintains the state of a TCP connection. So when first time a packet knocks on a layer 4 firewall to the last goodbye of that same session, layer 4 firewall maintains the state of that session. But as we had seen in previous example, what if a malicious attack is actually targeting protocol-based attacks like HTTPS or SSH or any other protocol, which is going to pass layer 4 firewall, which is only IP and port based? Nothing about protocol. That's where layer 7 firewall is leveraged to protect your workloads from protocol-based attacks.
WAF or Web Application Firewalls provide layer 7 visibility. With the WAF, you're able to see the HTTP request made by the requester. You're able to obtain detailed information such as the request headers, or the request body, or the response from the application. With the WAF, you're able to provide the ability to detect attacks such as SQL injection, cross-site scripting, etc. And these types of attacks are not visible at the network layer, so a standard firewall won't be able to provide that level of visibility.
We have talked a lot about network-based firewalls. However, we do have host-based firewalls as well. Host-based firewalls is installed and act at operating system level. For host-based firewall decision, you don't have to rely upon a network firewall. In this example, we are illustrating on the left side how a decision is made at firewall outside of 2 computers. And on the right side of the screen, a firewall decision is made within operating system of a computer. So once again, we have network-based firewalls and host-based firewalls. Network-based firewalls have to rely upon a network to get a firewall decision. On the contrary, host-based firewall can decide within an operating system. You may ask then, why not use host-based firewalls instead of a network-based firewall? Simple answer, use both. Because if an attacker has exploited an operating system, host-based firewall can be disabled within a computer. However, network-based firewall cannot be disabled, so it will give you another layer of defense for your workload, and both firewalls will be provided and used as defense in depth. So let's talk about Windows Firewall. Microsoft initiated and started, Internet Connection Firewall, also known as ICF, when they launched Windows 2000. By Windows 2008, Microsoft has fully stateful firewall as host firewall. Each firewall or Windows firewall currently can be divided into three profiles: domain, public, private. Domain profile is for those computers authenticated on your domain. So if you're working in an organization, all of those networks, all of those profiles will be clubbed as domain profile. Public profile for those from outside of your network. So you would treat outside traffic more carefully than traffic coming from another machine in your domain. Usually you will select these kind of profile for networks such as for a shared coffee shop, a library, or at the airport. And the last is private profile. That's where traffic from your own computer, nothing else. There are pre-built Windows firewall rules based on these three profiles. And I don't need to remind you all, make sure you have Windows Firewall logging enabled for all of your Windows hosts. Linux also has host-based firewall, and Linux introduced IP chains starting with kernel 2.2. Then also the next iteration of that was IPFW ADM. I would like to talk about IP tables. That's what we use day to day today with Linux Firewall. A lot of firewalls actually built based on IP tables. IP tables have three categories: packet filtering, network address translation, also known as NAT, and packet alteration. So let's talk about packet filtration. This table is essential. Packet filtering firewall has three standard chains: input, output, and forward. Input is for incoming packets. Output is for outgoing packets from your Linux machine. And if your Linux machine is acting as router, then forward chain will apply to routed packets. Second category or table is network address translation. If your Linux machine is acting as a gateway or a proxy server, this table will check outbound traffic which are performing network address translation, also known as NAT. And the last is packet alteration, also known as mangle table. This table is for special packet alteration. We don't see this as commonly used. Now, a quick difference between network-based firewall, host-based firewall. So most of the network-based firewall are hardware-based. However, there are some software-based networking firewall out there as well these days. And mostly host-based firewalls are software-based because they are embedded into your operating system. And as I said, network-based firewall implies it is at network level, host-based implies it is at operating system level. You would place your network-based firewall at the perimeter or border of the network. For your host-based firewall, it is installed and used for every single host. We call it end host system. Since network-based firewalls rely on IPs to build the rules, it's very difficult to migrate those rules from one organization to another. However, if you have few host-based firewall rules installed on your machine, even if that machine moves from one network to another, based on the profiles, based on the IP tables, or based on the firewall rules, they can be managed and move. Network-based firewalls are easy to scale. Not that host-based firewalls are not easy to scale, but it takes a bit of an effort to maintain those. Now, let's talk about a packet walk for a network-based firewall. From the left, we have a user PC with an IP address of 192.168.201.11. On the right, we have a web server with an IP address of 192.168.200.9. Not that these IP addresses matter, but for our packet walk and also for our demo, you might want to keep these IPs in mind. In between these two networks, we have a network-based firewall. So, question for you. Why did we not write down source port number in our previous example? Also, why did we not care about destination MAC address? If you need a quick refresher of the previous slide, here it is. Answer to the first question is because usually source ports are ephemeral and dynamically assigned. So they change frequently and mostly it's irrelevant for a firewall rule. It's not practical to have firewall rule with a source port except very special use cases. The Internet Assigned Numbers Authority, also known as IANA, suggests the range 49,152 to 65,535 for ephemeral ports, also known as dynamic or private ports. Second answer is when we are communicating outside our layer 2 broadcast domain, we use our default gateway IP to communicate. We do not need MAC address to ARP within a same layer 2 subnet. If it's too much networking, don't worry about it. Next, we'll only talk about firewall concepts, but keep in mind, networking is a foundation for any firewall understanding. Now, going back to our packet walk, user PC with an IP address of 192.168.201.11 and a web server with an IP address of 192.168.200.9. Packet will leave user PC via networks. It will arrive at the firewall for a decision of allow or block. Firewall, mostly it will have rules based on source IP, destination IP, and destination port. Once again, until firewall is verifying all the rules, firewall will not release the packet for destination. Firewall will cage or lock the packet to check all the firewall rules from top to bottom to match it before it can allow or block. Now, as I said, based on all configured rules and policies, if it will find all the rules are allow, it will release the packet to go forward to the destination. This is a typical example of layer 4 network-based firewall, where it would check an IP and the port. But what if one of the rules says to deny the source IP? Packet will not be released to go to destination and will be blocked at the firewall level. What about if one of the rules says to deny this destination IP? Once again, packet will not be released to go to destination and will be blocked at the firewall level. But what if one of the rules says to deny this destination port? Packet will not be released to go to destination and will be blocked at firewall level. Once again, this is a very common use case of our layer 4 network-based firewall. Now, let's say in our case, rules were configured to allow the packet to reach destination web server. So, the packet will move forward and the TCP state will be captured as it is a layer 4 stateful firewall. The packet will arrive at the web server. Now, return traffic will flip the source and destination IP. Source IP is web server IP, source port is what was originally destination port from the user PC, which is 443. And user PC IP becomes the destination IP. Now once again, destination port will be a dynamic port used by user PC to initiate traffic towards this web server. Packet will arrive back at the same firewall. Firewall will check the rules and now it will also record that the packet is a part of a TCP stream. Everything is fine as returned network traffic from web server to user PC through this network-based firewall or also layer 4 firewall. It will check the TCP state, it is allowed. Final step, the network traffic arrives at the user PC as a return traffic. As you can see in our example, network-based firewall has played a crucial role for both sides of network communication. From user PC to web server, network firewall has checked the network traffic and matched against the firewall rules. Same for return traffic from web server to user PC. Network firewall has inspected network traffic and maintains the state of this network communication. This is a typical walkthrough of a network-based firewall. Part of this session, we will be showing you a demo where we will show the importance of network-based firewall and web-based firewall. For our demo, we are using Kali Linux to simulate an attacker machine. We're using Ubuntu Linux to simulate a victim web server. And the last, we're using OWASP Juice Shop for a vulnerable web page. For this demo, we are using two commercial products, Palo Alto Firewall and Signal Sciences WAF. This session is neither sponsored nor reviewed by them. We are only using these products for our demo to be shared among community for educational purposes. In our lab topology, we have an attacker machine with an IP 192.168.200.9. Then we have a victim web server with an IP 192.168.201.11. In between these two machines, we have a network-based firewalls with rules to allow any source IP. In our case, which means attacker IP will be allowed to go to destination IP, which is a victim web server running a web server over port 80 only. So let's go with the lab topology. As you can see, this is my victim machine, which is running a web server 201.11. It is running the OWASP vulnerable juice shop. We're using Dockers to run this application, juice shop. Now from an attacker machine, I'm going to nmap to our victim machine webserver.com. As I can see, there is a port 22, 23, 80 and 3000 is open. So I can pick any one of these ports if I want to recon or attack. So I'll pick port 22. I'll try to SSH into it. I can see that I can do it. I don't have my password, but that's alright. But network firewall was still allowing me to do it. But what if I create a rule in my network firewall that I want to block 22? As on the screen it shows, it's being blocked right now, even though the port is open, but I cannot SSH into it as shown in this example here.
In this example, we're attacking the application by attempting a brute force login attempt. And in a real world, this would be an attacker attempting a dictionary attack with a bunch of logins and passwords. In Signal Sciences, you can see here that we're identifying login attempts and login failure. Here we've identified the number of login failure attempts. We've flagged the IP for the number of login failures that we see. We're able to actually define a threshold and action based on the number of login failures that we see. After the IP has been flagged, we're able to start blocking the login attempts after the threshold of login failures has occurred. As you can see in this example, we're seeing the number of requests that are now being blocked as a result of that threshold being breached. To be able to view the event, you're able to see the events page showing the number of requests that were tagged by login failures. And you're able to see how many login attempts we have now started to block. The next attack we're going to walk through is several cross-site scripting attempts. So here what we're doing as an attacker is we're attempting to inject a cross-site scripting script on the application. You can see now from Signal Sciences that we're able to actually identify the cross-site scripting attempt. Now, Signal Sciences takes a threshold approach where we see the first 50 cross-site scripting attempts, we're going to allow those number of requests, and that can be tuned to your needs. But in this case, we saw the 50 cross-site scripting attempts flag the IP, and now we have started to block any subsequent attacks from that IP. And if you go into the events page, you'll be able to see now that the IP has been flagged, and we are now blocking subsequent attacks from that IP address. The threat attack, it's not really an attack, this is more of just identifying anomalous behavior. In this case, what we're doing is we're actually identifying a request that does not contain a user agent. Typically, when you're seeing requests on your application, we would expect to see a user agent. Now, in some unique cases, you may not see a user agent, and that's okay. So that's why it's not considered an attack. But it's good to know whether or not you're seeing a user agent that is omitted from the request payload. So you can see how we're detecting that.
Now you have seen the demo. Let's wrap up the session by reviewing firewalls. Packet filtering firewalls, it's an early type of firewall security that relied on packet characteristics like source and destination IP address, port and protocol of individual packets to determine if the packet should be allowed through or dropped. Stateful inspection firewalls, this is a form of firewall protection added the capability to look at packets that belong to one complete session. Once a session is established, the source and destination are allowed to communicate without the need to look at subsequent packets in that session. Application layer firewalls. These network security firewalls examine packet level information and application layer information such as URL of the HTTP request. And the last is next generation firewall as a deep packet inspection tool that moves beyond port and protocol inspection and blocking to add application level inspection, intrusion prevention, and intelligence from outside the firewall. This is not to be confused with network intrusion prevention systems, which typically includes either a basic commodity firewall or consists of an appliance containing a poorly integrated firewall and IPS. Firewalls were originally hardware-based firewall. Software-based firewall just arrived on the scene. Software firewalls can now perform and scale similarly to their hardware-native counterparts for most use cases. The only real exceptions may be the largest and most demanding environments may require a heavy-duty firewall, which is a hardware firewall. Organizations today rely on cloud-based applications like Microsoft Office 365 and Salesforce, or infrastructures like Amazon Web Services or Microsoft Azure. Firewalls need to enable access to cloud applications and have the flexibility to be deployed in public cloud environments. Next-generation firewalls need to combine a full security feature set with capabilities like load balancing, traffic optimization, uplink modeling, and cloud access optimization from branch offices. Today's networks and business assets are much more dispersed, so the firewalls that protect them need to reflect that through extended secure connectivity capabilities. The most common denominator of all these viewpoints is that the firewall of today is quite different from those of a decade ago. The various software and hardware camps make liberal use of terminology such as virtual firewall and virtual appliances. Thus, virtualization has blurred the lines between what are or what were once quite distinct software and hardware-based firewalls. So, we have talked a lot about firewalls, but do firewalls have any limitations as well? Of course. Network firewalls are critical in providing perimeter security, but they are only part of an overall security posture that includes perimeter, network, endpoint, application, and data security, as well as policy management operations. Once the bad guys get in, and they will, other parts of the security infrastructure must come into play. And it's not enough to set up network firewall and forget it. Firewall maintenance is a crucial and often overlooked part of IT security. Stay tuned for our next session of fine-tuning firewall rules. Thank you very much.